All right, let's get started again. So, if I can, here we go. Unit 8, are landfills a good thing or a bad thing? So it should be both here, right? Because yeah, it's good to have someplace to put our stuff. It's bad in that all that stuff collects and builds toxicity in that leachate over time, and eventually it's going to erode through and enter our groundwater, which is not a great thing for those who like to drink clean water. So model a landfill, include all the parts. What are those parts, by the way? So for modeling a landfill, we know we have to have our lower layer here. All right, so we have to have that, that kind of plastic sheet, that lining. We've got tons and tons of clay all along here. We know on the inside, maybe even on the outside, all that clay and stuff, because we know that it does not allow water to leak through very fast. So that clay will at least help slow down this degradation process. But you got your plastic liner, you have all the clay along here. You're also gonna have some pipes, because as that leachate, that nasty, gross stuff starts leaking its way on down, we're going to want to be able to pull that out so it does not erode that liner too quickly. And then once we do pull it out, we can pull it up and then process it for chemicals. We can burn it. We can do any number of things. Now, all right, so we have our general outlay here. We're also at some point going to put some kind of cap over top of it. And when we put that cap over top of it, inside, all the bacteria are going to do is they're going to be breaking it down slowly and over long periods of time. And as bacteria do that, they break it down, they're going to produce lots of methane. And so we're going to have to pull that methane out, because that's, again, not great if it goes off and explodes. So we pull that out, and then we can actually burn it and use it to make energy to help maintain this landfill over time. One of the things they often do is we try to reclaim this area by putting like nice little parks and stuff over top of this land and making it more natural and beautiful and whatever. The general idea is this: you got to have a nice little bottom layer here, right, to hold the leachate in. You also want to have pipes pulling the leachate out, and that does show up. Line it with lots of silt and clay to slow down the flow of the water as it leaks into our groundwater if it ever does break through, and do something about all this methane that's being produced on the inside. Okay. Now, what will be the long-term effects of landfills? Long-term is they're just going to get more toxic and more terrible. The point of some landfills is decomposition. Some of them are trying to decompose that material as fast as they can. And what's doing that decomposition are bacteria. And through this process, as they break it down, they release chemicals, and some of the things just have chemicals in them, and water leaks its way down in through the surface as it rains. And so all that collects at the bottom, which is called leachate. And that's the nasty, really awful stuff that we have to pull out of the landfill. What gas do bacteria produce? We know that's methane. And when we do that gas, we burn it to generate electricity so that we can do our job. What is e-waste? E-waste is electronic waste, and why is it bad? Well, it's got tons of toxic, awful, terrible minerals inside it that have to be dealt with. So how should we dispose of our e-waste? We do not want to throw it out because of all the terrible metals inside. So we want to recycle that and reuse as much of it as we can. And there are certain e-waste recycling stations and plants around the country. Now, some solid waste is disposed of by incineration. You only have so much space in that landfill, and so when you're running out of room, one of the things you can maybe do is literally incinerate it and burn it. And so that can help deal with the preponderance of trash and solid waste that we're dealing with. What issues can incineration add to? Well, anytime you're burning something, you're releasing carbon dioxide in the atmosphere, which can contribute to global warming, which is not great. Why are rubber tires not allowed in landfills? So rubber tires, if you remember they don't break down anytime soon. And on top of that, they do nothing but hold water. And stagnant water, still water as we talked about, will tend to allow mosquitoes to grow. And that's where they lay all their eggs, in that stagnant water. So what effect does solid waste have on aquatic life? I think we mentioned this earlier, but all that trash ends up in our rivers and streams, and it can choke, it can kill, it can become ingested by some of these creatures. And those chemicals themselves are not great. So it has a lot of serious impacts on aquatic life. How does recycling help reduce global demand on minerals? This is really big. Recycling reduces global demand on minerals. And how? Well, you're reusing things, which means you don't need to dig up more. If you're digging up more, you have the issue of mining consequences. such as you have to like blow up mountainsides. You have to move all this dirt from deep underground, which means you're mining through all these toxic materials and minerals deep under the ground and exposing them on the surface, and then water lands on it and runs down through, and all those toxic metals from the mining you've been doing end up making their way through runoff into the rivers and streams, causing lots of issues. So we want to mine less. The best way to do that is to recycle. So it's a good thing for the environment that way. Now, in terms of why it could be bad for the environment, there are always pros and cons to everything. And if you're recycling a lot, that means you're using a lot of energy. And using a lot of energy right now still means that we're burning fossil fuels. So recycling wouldn't be quite as bad if we had more renewable resources used for our power generation, but we're still mainly on fossil fuels. Remember, I think it's like 80% of our economy is based off fossil fuels. So composting, what is it good for? Absolutely lots of things. Making fertilizer, finding ways to deal with trash, and on especially food waste and stuff like that, you can throw it in your composting bin. Of course, the problems are their rodents and odor. It doesn't smell great, and you're going to have an insect, and not to mention a rodent problem as they eat up all that food if they manage to get inside. Let me see. What's more important, reusing or reducing? You always want to reuse. Use something as long as you can. You got a plastic cup from, the movie theater, keep using it. McDonald's plastic cups, keep using them. You can throw them out, sure, but using them once isn't really great. We want to reuse them as much as possible. And we simply want to reduce. If you're reusing things and reducing the amount that you're using, that can be great. But I would say reduce. The less we use, then the less we have to reuse, and the less we have to recycle. So always try and reduce how much stuff you need. What does landfill mitigation mean? So anything that's being mitigated is typically going to be something that you are limiting. So landfill mitigation is trying to find some way to limit the effects of landfills. How does incineration and reclamation play a role? Well, if I incinerate it, I don't have as much trash in there, which means I'm mitigating its effects. And reclamation means I'm covering it up and putting in something nice and pretty and beautiful to hide the fact that there's a bunch of hot, smelly trash under our feet. Yeah. What can the methane produced be used for? Well, we can use it for energy. I'm very much repetitive on this, I see. Anyways, describe the process of sewage treatment. Step 1, raw sewage. Nasty, awful crap, literally. So we screen it, right? Pull out the big parts, like the half parts of cars and things that we talked about before. Anyway, so you screen out all the junk, and then you're left with poop water. So in the poop water, you send it down here, stage 2, and let it settle. All the nasty, gunky, heavy, dense stuff will sink to the bottom. All the fatty, yucky stuff will float to the top. And then you can simply just skim, right? Take all of that nasty poop, called the grit, and dispose of it. You can see here the sludge as it's being disposed of here. But you can actually use that sludge to power the plant by burning it, which is kind of nice. And you can scrape stuff off the top. We call this the clarifying chamber here. So it's clearing it up a little bit by scraping the stuff off after it's settled for a while. Anyway, so you send that less toxic material all the way up here, and then you start to aerate it. So now that you've minimized the amount of poop waste in there, you still have all that gross water. Well, you need bacteria to do their job. Their job is to decompose it. So break down all this nasty stuff that makes me sick. So we do a secondary treatment here where we, again, just break down all the materials as much as we can and then let it settle. You'll notice the aeration part here, which means they're using aerobic bacteria. So they're putting in lots of air to help the bacteria do their job and decompose. And then again, let that nasty stuff settle to the bottom. And as it settles out, you can skim it, and it leaves you with clear water. Not clean water, clear water. The problem is, of course, all the bacteria you just used are still floating around in there, and they would make people sick. So the last thing you do is you add in a disinfectant of some kind. You could do UV radiation, you could do chlorine, you can do fluorine. Any of those little things will help kill off some of these bacteria. And then you can release it back into our lakes, rivers, and streams, or you can rotate it back into people's drinking water, depending on what you want to do there. All right, let's see here. So what is the aeration for? Again, that's for the aerobic bacteria. The disinfectant kills the bacteria when you're done with them. And that's kind of the ins and outs of poop water. Now, what is this? this is our, no idea? Okay. Well, anyways, it's our little chart here about what we call LD50, lethal dose 50, but we have lots of these kind of unique curves here, including the following: therapeutic, toxic, and lethal. So therapeutic, that is the little curve here that shows at what point it becomes effective. The ED50, or therapeutic effect here, happens, 50% of the population is benefiting from this at this specific amount. And as you continue here, eventually that amount is no longer therapeutic, it starts to become toxic because you got too much of it. And that's the TD50. But the one you really have to know about is the LD50, the point at which the amount of chemical in the actual, whatever you're drinking, water or whatever, is lethal to 50% of the population. That means half the people who drink it, or eat it, or ingest it, or it's the same thing, or inject it into their bodies are going to start dying. And that's not great. So, what does therapeutic mean? Anything that's therapeutic makes you feel better. Toxic makes you sick. Lethal kills you. And a threshold is that moment where that line starts to go up. It reaches the threshold, the point at which things can kind of like get worse. That's the threshold. What does LD50 mean? The point at which 50% of the population would die. Why is it hard for anyone to prove that a certain chemical is causing them to experience cancer? It's hard to prove that. You remember from the case study we had, it's hard to prove that because there are so many different things that can cause cancer. Sunlight, just breathing in the air that may be filled with ozone or VOCs or whatever, or mesothelioma. Like, there's so many things that could be contributing to someone's cancer. Their genetics alone can cause cancer. It's a really tough thing to prove for anybody. However, as we saw from the article we read, dousing yourself in pesticides or herbicides, I'm not sure what, I think it might have been herbicides, was not great for that guy's health. But it's still hard to prove it and win those cases. Now, what is dysentery? That's when you're pooping all the time, but not pooping, you're having diarrhea, incessant diarrhea, and cholera we know is one of those types of things. What causes it? Some kind of internal bacteria. Giardia is one that I often hear about. That's the one I remember from Katrina in New Orleans. People were getting sick with Giardia because they were accidentally ingesting some of the water in that area, and it was filled with Giardia, which can cause severe diarrhea and dysentery. What is mesothelioma? And that's the cancer inside your lungs caused by asbestos, which we use as insulation in walls. What is ozone? Ozone is supposed to be in the atmosphere, specifically the stratosphere, protecting us from UV rays. Unfortunately, we also make it through poor combustion inside our engines. And when you're doing poor combustion and making lots of ozone, it's in the troposphere, which means the lower layer of the earth where we are. And that means we breathe it in and we can get very sick and have serious respiratory and lung issues and diseases. What is a pathogen? Simply speaking here, a pathogen is some kind of bacterium or virus that makes you sick. How do they relate to evolution? Well, especially viruses, when they go into your body, they start to be copied and transcribed and all that good stuff and translated, I guess. But anyway, so going through that whole process, and lots of mistakes are made. And when mistakes are made, they change the kind of virus. So oftentimes, that is how a species of virus will jump from, say, a bat to a human. Because you have all this mutation going on, and then the new virus that's created through these accidents has access to human cells as well, and it can jump species. So that's how evolution helps them. Evolution is just the changing of DNA over time, and oftentimes taking advantage of some kind of need and some kind of new environment. In this case, humans and human cells. Can any environment be perfectly clean? And the answer is no. You can try as much as you want, but there's still bacteria floating through the air at all times. It's one of the problems with hospitals. They're having a real issue with MRSA, better known as MRSA, or methicillin resistant. Methicillin, I'm pretty sure I'm not spelling that right. But anyways, methicillin resistant Staphylococcus aureus. Staphylococcus aureus being a bacteria, and it's methicillin resistant. which means it resists the antibiotic methicillin. Methicillin similar to penicillin, right? And so when you're methicillin resistant, that means that it's going to be hard to kill you. So it's hard to kill. Methicillin resistant means the bacteria is hard to kill, and that means that if it takes over and gets into someone's infection, you go in for surgery on your ankle, and you're getting ankle surgery, and they're going through it, they're putting things back together, they sew you up, and some MRSA, methicillin-resistant Staphylococcus aureus, gets in there, it's going to start just devouring your ankle, and no matter how many antibiotics you take, it's not going to kill that bacterium, and that's kind of an issue here. So you can be as perfectly clean as you want, but MRSA in hospitals is a real concern situation. That's why you see everything's always covered in that blue paper, and they're washing their hands and their elbows, they're covering their faces with masks and their heads and their hair and their shoes, just trying to keep as many bacteria out of the operating room as possible. A vector is some means of infection, some way the infection gets from one person to the next. And why are poverty-stricken, low-income areas more prone to disease? For these two reasons. Sanitary waste disposal. Remember, in the medieval times, Middle Ages, people would just shut their buckets of poop water out of the window onto walking people, right? They're just walking along, get this dose of terrible poop water, makes you sick, or it just lands on the ground. And when it lands on the ground, it festers and stuff, and the rain washes it into your streams and rivers where people are trying to drink from. And so people got sick a lot in those kinds of days. So clean drinking water and sanitary waste disposal are very important. We talked about Bill Gates and his toilets being so important for both of these reasons. Describe or model the transmission of the bubonic plague. If you remember, we had the rat. The rat had a tick on it. That's this cat now. Is that cat or rat? The rat had a tick on it. The tick would then bite the human, and then the human would get sick and die. And on and on and on it continued. That's a basic look there. What is tuberculosis? All right, hustling this along. What is tuberculosis? Well, that's where you're coughing up that terrible, awful pathogen, that bacterium, right? That goes into water droplets in the air. Someone breathes in, it goes into their lungs, and it sits and waits, and over time slowly decays their lungs. You'll know it if someone's coughing into their handkerchief. They called it consumption in the old days. And you see blood, that means you're coughing up pieces of their lungs because the bacteria is literally eating it. How is it spread? By, again, people coughing. Treatments, we don't really have any beyond antibiotics, which have helped a lot. We don't use vaccines anymore because people don't have as much. But antibiotics are really good at treating it. What is malaria? Malaria is when you're bit by a mosquito, especially in areas along the equator, because there's so much rainfall along the equator. And all that rainfall means you get lots of mosquitoes, and therefore human beings around the equator are very susceptible to malaria, and it's killed more humans than anything else in the history of time. So people in sub-Saharan Africa are particularly at risk, and that's why people of African descent typically have the sickle cell trait, which is where their blood cells have a weird shape to it that prevents malaria from entering the cell, and malaria will attack people's blood cells and kill them that way. So the sickle cell shape helps keep them alive. It does make it harder for them. Like if you have a weirdly shaped blood cell, you're not going to be able to breathe as easily as most people or exercise as much. So that's where it kind of becomes an issue. So treatments, though, we do have vaccines, but the main problem is, of course, distributing those, and especially in poverty-stricken countries where there's not really a whole lot of money to buy those kinds of things. What is West Nile? I believe that they said that this was passed on from birds and mosquitoes, I think, biting birds, and then it getting to humans from there. So transmitted through that process. And the symptoms are just kind of like a general sickness. What is SARS? Severe acute respiratory syndrome. And it's transferred in the case of SARS by just coughing and getting sick from people who happen to have it around you. What is MERS? That's the Middle East respiratory syndrome. It's basically another COVID, another coronavirus. And again, just transmitted simply enough by coughing and sneezing and poor sanitary habits like washing your hands. Zika. Zika is a virus that is spread by mosquitoes. The mosquito would bite a human infected with Zika, and then carry it and bite somebody else infected with Zika. No, bite somebody else and then infect them with Zika. So transmitted by the bites of mosquitoes or any kind of blood-to-blood contact, which can be sexual or in the case of blood transfusions. You should be very careful. And we know that Zika could cause severe impacts on developing fetuses, and that's kind of the big deal for me, especially when Maverick was born. I think I talked about that. And what is cholera? It's just another form of dysentery, right? You drink or eat food prepared with unsanitary water, and that unsanitary water with raw sewage and stuff in it, basically from the poop water, if you will, gets into your system, and cholera invades your colon, doesn't let you absorb water, and you basically just poop, or I should say you have diarrhea with like liquid and cholera coming out of your behind for as long as it takes for you to die. And so cholera is a pretty miserable way to go. Death by dysentery is not fun. Anyways, you can get bloody diarrhea and die. So on that wonderful note, that's all you need to know for your test. And as always, email me if you have any questions. I'll see you guys Thursday.